Hello, and welcome to our presentation on our project submitted to Social Media Mining for Health Research and Applications 2024 shared tasks. The title of our work is Analyzing Social Anxiety Effects Through Context-Aware Reddit Learning or Context-Aware Transfer Learning on Reddit Data. And this work has been worked on by myself, Sheikh Rahman, and Azmine Toushik Wasi. So what was the task that was given to us? So this was task 3 of the shared task for SMM4H of SMM4H workshop. And in this task, we were given like several posts made on the r/slash social anxiety subreddit, where the posters essentially talked about their social anxiety and how it affected their daily lives. Along with those, we were given keywords that referenced one or more outdoor activities like running, jogging, or hiking. And the task that we were given was that we had to classify the post based on the effect of the outdoor activity on the social anxiety of the person who made the post. So there were four different effects, or like three effects and like one extra class. So the three effects were the keyword or the like outdoor activity having a positive effect on the social anxiety of the poster, a negative effect, or like having no effect at all. And there was also fourth class where essentially the keyword is not actually referencing an outdoor activity. An example of which would be like the word surfing, which can, for instance, in the sentence like I was surfing the web, the word surf doesn't actually mention the outdoor activity of surfing, but actually mentions me browsing the internet, right? So in that case, the keyword is not actually referencing outdoor activity. So what was the purpose of this task? So the key idea is that before seeking medical help, people often turn to social media sites like Reddit to talk about their experiencing regarding social anxiety. And the idea is that we can glean useful information from these posts. And this task essentially forwards studies on the specific effects different outdoor activities can have on social anxiety disorder. So in this dataset, we were given like 1800 training data points, 600 for like validation and 600 for tests. So in this case, like one data point means that one pair of like post and like the keywords that were given. So moving on, what was our approach to this particular problem? So we had like the key idea in our approach was using fuzzy string matching to strip down the text in the post. So what do we mean by that? We essentially used the fuzzy wuzzy Python library to find sentences containing the given keywords. So we used like fuzzy string matching because like the keywords, the spelling in the keywords might not exactly match with the spelling that was used in the post and things like that, right? So we had to kind of like take into account and then like search for those strings. So after we found the keywords in those sentences, we essentially like strip down the post by selecting the sentences that contain the keyword, selecting the preceding sentence, as well as selecting the succeeding sentence, and then discarding the rest of the post entirely. So the exact methodology was we used that we matched the keywords along with the keywords by using Levenstein distance for fuzzy matching, and we only selected keywords who had a similarity score of at least 90 and whose length was at least 3, so that we don't get like nonsensical words being selected, right? So the key idea behind this was that we wanted to make it easier for our models to focus on the context that was relevant to the keywords that we had to classify, and kind of like get rid of all the extraneous information that kind of like was contained in this post. So what was the model we used over here? So the model is pretty simple. We first used the Roberto tokenizer to tokenize the stripped sentences, and then we used a model which used a pre-trained Roberto model as its backbone, along with like and then pass it through like a dense layer followed by patch normalization and redo activation function, followed by a dropout layer, and then finally another dense layer that actually performed the final classification. So what are some of the implementation details here? So the configuration for the tokenizer is that we limited the kind of like the maximum length of the input to 256 tokens, and we use like lowercase text processing. So in our model architecture, in our best performing model, in our best performing models, the dense layers had like 1024 nodes for the Roberta large variant of the model, and 768 for the Roberta base variant of the model. So it has different like a number of nodes in, because like the two models have like different embedding sizes, and we had to adjust it accordingly. We also use like sigmoid activation function and ReLU between the layers with dropouts. As for batch sizes, we use like 8 for for the training batch size and 4 for the validation and test batch sizes. And for the training parameters, it was pretty straightforward. We used a learning rate of like 1 e to the power minus 5, and we use like categorical cross entropy loss with Adam optimizer. As for the random seeds, all of those were set to 42. We trained our models for 20 epochs, and we didn't use any additional data. Moving on, we let's look at the results that we obtained over here. So essentially, we trained two different models. The first one was the Roberta base, and the second was Roberta large. And we tested out different like variations of the hyperparameters. For example, for some models we had like we turned on fuzzy string matching, and for some we didn't use fuzzy string matching, meaning that we kind of like fed the raw posts made by the users into the model, to kind of like compare as to whether like fuzzy string matching has any kind of like advantages or not. We also varied the dropout between like zero point 0.3 and zero point 0.4. And as for the results, we can see that for the training phase, Roberta base without fuzzy string matching actually works the best. But we can see that it doesn't really generalize very well, and we can see that when fuzzy string matching is actually used, the model really generalizes very well to the validation set, as we can see over here from the table and like the highlighted scores over here. We can see that the models that use fuzzy string matching usually outperform the other ones. And we have another table over here to really like kind of like show that fuzzy string matching as actually like improves performance. As we can see over here, for all of the hyperparameter configurations, we see that using fuzzy string matching actually help the models outperform their corresponding models that didn't use fuzzy string matching. So moving on, we found out the results on our test set, and here essentially for the task we submitted three different models or three different variants of our models. The first was a Roberta base with fuzzy string matching. The second was Roberta large without any fuzzy string matching, and the third was a Roberta large with fuzzy string matching. And we can see from the results over here is that the Roberta large with fuzzy string matching outperformed the other models, and we can also see that we got a validation macro F1 score of we got a test macro F1 score of 0.654, which far outperforms the median score for this task, which was only like a 0.5795, showing that our approach had like advantages over like other approaches. And furthermore, we also used a dropout of zero point 0.4 and trained them for 20 epochs in our best performing models. So what do we find from this study over here? We can see that using the Roberta Large pre-trained model, we essentially obtained the text embeddings and then fine-tuned them with MLP classifiers, which was the approach that worked the best. We also made some like further kind of like adjustments to the model layers and hyperparameters. By kind of like fine-tuning them, we were able to find the best performing hyperparameters. And additionally, like stripping the text input by making them smaller using fuzzy string matching approach actually boosted the performance for all of our tested hyperparameter configurations. And finally, we can see that we achieved a best score of like 0.651 macrophone score on the 0.654 macrophone score on the test set, which far outperformed the kind of like the median score for that task, and it demonstrated the effectiveness of our approach. And that's all. Thank you for listening.